Good morning, everybody. It's good to have you tuning in today. For you, I'm glad that you're hanging in there and doing what needs to be done, paying attention to your needs, because we know that on the other side of this whole thing, there's a hope and a future. So when you're doing this, think about it as this is not for nothing. This is because when we're all done here, you guys want to be in the best shape that you can, because God ultimately does have a plan for you. And so I'm happy to be here, being able to do this for you and with you. I know that this morning I've had some technical difficulties. This is take 2 for me because my batteries died. So hoping that this one will come out the way that it's supposed to be. It was great the first time, so hopefully this second time when the voice is actually being recorded will be just as good. I'm sharing this with you because, we're here all doing this in real life, and every one of us has struggles. And I want to encourage you that even though in the world there's trouble, we can take heart because Jesus has overcome the world for us, so we need to take heart in everything, even in the small setbacks. So that's an encouraging word for you today, faithful Algebra 2 students who are logging in and doing this, and really making sure that you're set for your future and for your hope. So let's just move right along, and let's take a look at what happens with rational exponents. What we need to remember is that in rational exponents, that when you have like bases, you can still add exponents, just like when we were doing with regular exponents. So 1/5 plus 4/5 is 5/5. 5/5 is 1. So this is really just kind of a fancy way of writing a 7, because 7 is our base and it's taken to the first power. Remember, your power to a power rule with regular plain old numbers is that when we have a power raised to a power, we can then just multiply these exponents. So 1/5 times 10, you should realize, is a 2. So 3 squared turns out to be 9, and you can simplify that down very nicely. Today is a minimal calculator lesson, so a lot of these things can be done even by hand if you're feeling awake. So 4 times 5 to the 1/2 power, we're going to use the rule that when you have a product to a power, that each one of these gets that exponent brought into it, because this is really AB times AB times AB this many times, so there's the same number of A's as there are B's here. So this 4 to the 1/2 times 5 to the 1/2, we know that this is our index in our radical. So this is really a fancy way of saying the square root of 4, which we know. But 5 to the 1/2 power. Notice that when you just have the exponent next to one specific number, that the exponent only applies to that. So we've simplified the 2. But the 5 is keeping that half power because it doesn't simplify down to anything lower than that when you're simplifying. All right, let's move on. Don't forget your rules for negative exponents. A negative exponent means that it's the same as 1 over that number to the power. So 1 over 9 to the 1/2 power is the same as saying 1/3, because the square root of 9 does turn out to be a 3. Don't forget also, when you have like bases and it's in a fraction, you can solve that by simply subtracting the exponents. So here we have 5/2 minus 3/2, and that gives you 2/2, which we know is 1. So 6 to the first power gives us a nice friendly 6 that's super easy to think about. When you have a fraction to a power, this is really like A over B times A over B times A over B, however many times this is. So that's where we get the idea that there's just as many of these as these, even if it's a fractional exponent. So 5 to the 1/3 over 8 to the 1/3. We know that this is our index in our denominator, so the cube root of 8, and in the numerator 5 to the 1/3 power. We can use these fractional rational exponents in order to simplify when you have radicals that don't appear like you can do anything with them. They're different indexes, they're different exponents, but when we start to write them with their rational exponents, 3 over 4 and 2 over 8, and then we simplify our fractions because you know how to do that. 3/4 is just 3/4, but 2/8, if you remember when you simplify that, turns into 1/4. So we can then subtract 3/4 minus 1/4, which gives you 2/4, and 2/4 is the same as a half. So it simplifies right down into the square root of x. We can use our exponents here as well. Our exponents sometimes are hiding, like this one has a 1 as its hidden exponent, so this is a 1/3. This also has a 1, so that's a 1/4. And when we add our exponents, I just want to pull to the side for a minute and remind you of how to add exponents. So when we recall that if you're going to take 1/3 and you're going to add it to 1/4, don't forget you need to have common denominators. A good quick way of finding common denominators is simply to multiply these two denominators together, and you get this. So this one was multiplied times 4, and this one was multiplied times 3. I'm reminding you of this because down the road here, not too far, we're going to be using this in a whole different way. So we have 7/12 for your exponent. Oops, not that. 7/12 as our exponent, which means our 12 is our index and our 7 is our power. So the 12th root of 3 to the 7th, and we have that. Moving right along, we've got our decimal to fraction. Just as a very, very quick review, if you want to take 2.5 and you want to make it into a fraction, that's 2 5/10. 5/10 reduces to a half. As an improper fraction, 2 times 2 is 4, plus 1 is 5. We want to think about the improper fraction version when we do this problem. And then remember that it's a negative exponent, so that throws the whole thing into the denominator. And then realize that we have a square root to the 5th power. Most of these, it's more convenient to take the root first and then the power. So the square root of 16 is 4, 4 to the 5th power. And 4 to the 5th power turns out to be 1024. Now you can use your calculator that you have for that by taking 4 to the 5th power. As many of you did buy this, as I had told you guys to do at the beginning of the year, but even if you didn't, you can use your calculator from your computer or from your phone. If you go into the scientific mode, that's usually where you have something like x to the y power. So if I wanted to take this one, if I wanted to take 4 to the 5th power, I can do 4. Oops, that's not what I wanted to do. I can take 4 5th power, 4 to the 5th power, 1024. This one down here, this is we're going to take the fifth root of negative 32 and take it to the fourth power. We're reversing the process here so that we can simplify this. Fifth root of negative 32, what number times itself, times itself, times itself, times itself? So we're thinking negative 2. Times negative 2 is 4, times negative 2 is negative 8, times negative 2 is 16, times negative 2 is negative 32. To the fourth power, multiply it all back out again until we get to positive 16. These things are things that you can do in your head or on paper pretty quickly. So you can use the calculator, but it's not 100% necessary. Right here, once again, we want to get our exponent dealt with. You can either bring it to the denominator first, or you can change it to an improper fraction first. Either one will work. Remember, our negative exponent brings things to the bottom in order to make it positive. So that's 7/2 would be our exponent there. This is the index, this is the power. So the square root of 9 is 3. And to the 7th power, I already kind of pre-did this one, 3 to the 7th power, just to remind you of this. 3 to the 7th power, in case you're using that. I just hit 4. I mean 7. There we go, 2187. Or in your calculator that you need for the more advanced things, 3 to the 7th power, 2187. Then over here, once again, take your power and your root. Usually more convenient to take your root first. And so we take the fourth root of 16, which gives you 2. And then 2 cubed, which gives you 8. And hopefully this is coming out and you're going, oh, okay, I get this. This is pretty easy. But if not, please don't forget to shoot me a question on that form, and I'll be able to see it. All right, here we go. This one. Lots of things happening here because we've got these parentheses, we've got this square root, so we have to think about all of the different things that can happen here. First of all, this power has to apply to every single piece. Okay. This power has to apply to every single piece. Now this is its own piece because the square root of y acts as its own unit here. No, don't forget then that we're going to take the cube root of negative 8 and square it. This one I'm going to leave alone as being 2/3 for a moment. This, if I take this, we still have our 2/3 hanging out here, but let's make this into the half powers, because each one of these has a power of 1 and a root of 2. Power of 1, index of 2. All right, so this one's coming along nicely. That's going to be negative 2 squared. This one we're still leaving as x to the 2/3 power. This 2/3 gets multiplied in times each one of those pieces. So 1/2 times 2/3, don't forget that you can cancel out that, so you end up with 1/3. 1/2 times 2/3, you're still canceling that out, so you get y to the 1/3 power. I want to gather some things up and simplify even more. Negative 2 squared gives you 4. X to the 2/3, x to the 1/3, you've got common like bases, so you can add those exponents. And y to the 1/3 we have to leave alone. So 2/3 and 1/3 gives you 1. And y to the 1/3 can be simplified down to the cube root of y. Usually when they say simplify completely, you want a radical form in your end when you finally brought it down and done everything that you can do. And so here we have the most simplified form of this by applying all of the rules to exponents. I like this problem because it basically uses everything except for negative exponents, but it uses an awful lot. All right, last one for the day. We've got a negative exponent. You don't need to bring it down right away. You can go ahead and bring that exponent in just by multiplying 1/3 times, well, 1/3 times 1 is 1/3, or negative 1/3. Negative 1/3 times 15 is negative 5. We can bring them down to the denominators. The cube root of 8 very nicely will simplify for us so that you get 2 and you get x to the 5th. So this is really 1 over 2 x to the 5th. I hope that you have a really good and wonderful day today. And if not, then I'm praying for you, and just please remember to keep those prayer requests coming, and just believe that God's got a plan for you and that it's going to happen, and it might just look different than what any of us expected when we woke up 3 weeks ago. All right? I love you all. God bless you, and have a wonderful day.